Be using partial fractions. So we have been given this question, L inverse of 3s positive 2 divided by s negative 1 times s negative 2. So what I have done here is I have taken this quantity separately and I have rewritten as 3s positive 2 divided by s negative 1 times s negative 2 to be equal to a over s negative 1 positive b over s negative 2. Then what I would do is I would cross multiply, and that would give me a times of s negative 2 positive b times of s negative 1. Now the idea is to get rid of the quantities one by one. So if I want to get rid of this quantity a, I would just say put s to be equal to 2 in 1. So I take this as 1. So if I were to take s is equal to 2, this will vanish, leaving me with b times of 2 negative 1. On the left side it's going to be 3 times of 2 positive 2. 3 times 2 6, 6, 7, 8, and this is going to be b. So this means I got the value of b as 8. Now next I can get rid of b now. So for that I would say put s is equal to 1. When I do that, this is going to be b will vanish. So I will have a of 1 negative 2. On the left hand side it's going to be 3 times of 1 positive 2. So it's going to be 3 positive 2 is equal to negative a. So 5 is equal to negative a. So therefore I get the value of a to be as negative 5. So I've got a value for a, I got a value for b. All that I will do is, hence we can now rewrite 3s positive 2 divided by s negative 1 times s negative 2 to be as negative 5 over s negative 1 positive 8 over s negative 2. So wherever I find this quantity, I can replace this with this quantity. So that's all about. So let's do that. So hence I can rewrite this. If I were to take this as 1 prime, so therefore 1 prime becomes L inverse of, in place of this entire component I'm going to use negative 5 over s negative 1 positive 8 over s negative 2. By linearity I can rewrite this as negative times of L inverse of 5 over s negative 1 positive L inverse of 8 over s negative 2. So this is going to be, I can take the 5 out and I write this as L inverse of 1 over s negative 1. I can take the 8 out and write this as L inverse of 1 over s negative 2. So this is going to be negative 5 times, shift is s negative 1, so we are going to get e raised to the power of t, positive 8 times, this is going to be e raised to the power of 2t. So this is my solution to this question. Students, we are given this question to find the Laplace inverse of 6 positive s negative 1 times s squared negative 5s positive 11, that is being divided by s times of s negative 1 times of s negative 2 times of s positive 1. So what I would do is, first I would have to use partial fractions. As you are aware that all of these questions would be using partial fractions to solve. So having mentioned that, let me just consider the numerator. 6 positive s negative 1 times s squared negative 5 times s positive 11 divided by s of s negative 1 times s negative 2 times s positive 1. I can rewrite this as a over s positive b over s negative 1 positive c over s negative 2 positive d over s positive 1. Now if I were to cross multiply, I would get 6 positive s negative 1 times s squared negative 5 times s positive 11 to be equal to a times of. Now the s gets cancelled, giving me s negative 1 times s negative 2 times s positive 1, followed by my b, which is going to be s negative 1 gets cancelled, so I will have a s, I'll have a s followed by s negative 2 and s positive 1, and then for c I will have a s and then s negative 1 and then s positive 1, followed by for my d I will have a s negative 1 and s negative 2. So now we will have to find the values for a, b, c and d. So how are we going to do that? Foremost, if I were to take s is equal to 0, this is the easiest one. Let s be equal to 0. When I take s is equal to 0, this vanishes, this vanishes, this vanishes, but the value for a will stay put. So 0 minus 1 times 0 minus 2 times 0 positive 1, which is negative times negative will be positive, so that's going to be the 2 there, and I have a 1 here. 2 times 1, that's going to be 2a. S is equal to 0, so this is going to be 6 positive, that's negative 1 there. This will vanish, you get a 11 there. So in fact you get 6 negative 11, that was going to be 5, right? So this is going to give me negative 5. Therefore the value of a is going to be negative 5 over 2. This is my first value. Now I've got the value for a. Now let's move on. Next I would like to take s to be equal to 1. So if I were to take s is equal to 1, this will vanish, this will vanish, this will vanish, but b will stay on. So let me use the space here to obtain the value for b. So it's going to be b of 1, 1 negative 2 times 1 positive 1. I get a negative 1 here, this is 2 negative 2, so it's going to be negative 2 times b. On the left side I need to substitute s is equal to 1. If I substitute s is equal to 1, this goes off clearly, right? S is equal to 1, this entire thing will become 0. I just get a 6. So 2 divides 6 3 times, so therefore the value of b is negative 3. Okay, I got a value for b, and now it's time for me to obtain the value for c. Now to get the value for c, I would, let me just take s to be equal to positive 2 first. Let me get rid of d. So I'm using this space here. So let s be equal to 2. If I were to take s is equal to 2, this will vanish, this will vanish, this will vanish, but this would not vanish. So it's going to be c of 2 times 2 negative 1 will give me 1, 2 positive 1 will give me 3. So on the left side I got s is equal to 2, so 2 minus 1 will give me 1. This is s squared, so it's going to be 4 negative 10 positive 11, right? So 4 added with 11 will give me 15. 15 minus 10 will give me 5. So this is going to give me 5 plus 6, that's going to give me 11. So let me just check one more time. S is equal to 2, 2 squared is 4, 10 and 11, 11 added with 4, 15, and then I get a 5. That's right, 5 added with 6 will give me 11. That's fine. 3 times 2 is 6, so therefore my value of C is 11 over 6. So fair enough. So I was able to get the value for A, B, C. Now we need to get the value for D. Now for D, I can substitute, say S is equal to any value. It doesn't matter, because we would ultimately arrive with A, B, C, and subsequently we can use these. So let us just check out the shortest way by which we can obtain the value for D. Okay, the best thing to do is substitute S is equal to -1. If I were to take S is equal to -1, then S is equal to -1, this will vanish, this will vanish, this will vanish, and all that we have is only D. So let me just evaluate the value for D here. So -1, that's going to be D of -1. -1 will give me -2. -1, -2 will give me -3. That's fine. So negative positive, 3 times 2 or 2 times 3 will give me 6. With 6 times -1 will give me -6 times D. On the left hand side it's -1. So if I were to place -1, this would be -2. -1 squared will be 1. -1, that's going to be +5, +11. 5 added with 1 will give me 6. 6 added with 11 gives me 17 times 2, -34. So I have a -34 added with a +6, that's going to give me 28 with a negative sign. So I get a -28. So positive, so 28 divided by 6. So therefore my D is going to be 28 divided by 6. So 2 divides here 14, 2 divides here 3 times, so 14 over 3. So this is going to be 14 over 3. This is my D value. So let me write the values down. I've got A to be as -5 over 2. This is my value for A. My value for B is -3. My value for C is 11 over 6, and my value for D is 14 over 3. Now the question comes, we will have to substitute all of these values and then obtain the Laplace. So let's do this. So wherever I find this, I would have to replace this. So in fact what I can do is, probably I can just use this space over here and finish it off, because probably I can retain my continuity. So this entire thing will be equal to L inverse of -5 over 2 divided by S, followed by positive of -3 over S -1, followed by 11 over 6 divided by S -2, followed by 14 over 3 divided by S +1. So by linear property we can use linearity in Laplace inverse. So that would give me -5 over 2 times L inverse of 1 over S, L inverse of 1 over S, followed by -3 L inverse of 1 over S -1, followed by 11 over 6 L inverse of 1 over S -2, followed by 14 over 3 L inverse of 1 over S +1. So this is what I have got. Now if I can obtain the corresponding values, then the question is finished. So this quantity L inverse of 1 over S is going to be 1, so I can safely write that to be as -5 over 2, followed by -3, 1 over S -1, that's going to be e raised to the power of +t, followed by 11 over 6, 1 over s negative 2, that's going to be e raised to the power of 2t, and followed by 14 over 3, and 1 over s positive 1 is going to be e raised to the power of negative t. So this is the solution for this question, students. I hope you had followed this. So we will move on to the next one. Students, we are given this question. We are expected to find the Laplace inverse of 8 negative of s positive 2 times 4s positive 10 divided by s positive 1 times s positive 2 raised to the power of 2. Now this can be done by partial fractions, but the technique is a bit different. So I'm going to show you the technique. So foremost, what we will do is we will consider this quantity. That's what I'm going to do. Consider 8 negative of s positive 2 times 4 times s positive 10 divided by s positive 1 times s positive 2 raised to the power of 2. Now I'm going to rewrite this as a over s positive 1 positive b over, now you got this s positive 2 raised to the power of 2, right? So we will split this as s positive 2 for the first quantity, and then for the second quantity I'm going to split this, in fact I'm going to write it as it is, s positive 2 raised to the power of 2. So this is the pattern in which you will have to use the partial fractions whenever you encounter a pattern of this form. So it's all pattern matching. Now if I were to cross multiply this, I would get 8 negative of s positive 2 times 4 times s positive 10 is equal to a times of s positive 1 gets cancelled, giving me s positive 2 raised to the power of 2, followed by b times of s positive 2. I will have one s positive 1, in fact I will just have a s positive 1 followed by an s positive 2, and then that will be followed by c times s positive 2 whole square will be absorbed, giving me c times of s positive 1. So this is what I've got. Now I have to find the values of a, b and c. So the best way is just take the value for s to be as, say, negative 2. If I were to take s to be as negative 2, what happens? This one gets vanished, this one gets vanished, and I would be left with this. So it's going to be c of negative 2 positive 1. On the left side, negative 2, everything goes off, so I get 8 here. So this is going to be negative 2 positive 1 will give me negative c followed by 8, therefore the value of c is negative 8. So successfully I got one value of the quantities that listed here. Next, what I wish to do is I would like to take s to be equal to negative 1. So when I take s to be negative 1, this vanishes, but this stays. So this is going to be a of negative 1 positive 2 raised to the power of 2. So that will give me a positive value here. So it's just going to be a. And on the left hand side, I have taken s to be as negative 1. Apparently I will have to substitute the values. So it's going to be 8 negative of negative 1 positive 2 of 4 times of negative 1 positive 10. So this is what I've got. So this is going to be 8 negative of negative 1 positive 2 will be positive 1, and 4 times of negative 1 will be negative 4, and positive 10 is equal to a. So this is going to give me 6, and 8 negative 6 is equal to a, therefore the value of a is going to be 2. So this is what I've got. A is equal to 2, and I've got a value for c. Now next I will have to obtain the value for b. So let's do that. Now to get the value for b, you can just simply substitute s to be equal to 0. Let s to be equal to 0. So that would give you 0 here. So let me write that down. 0 positive 2 squared positive b times of 1 positive of 2 positive c of 1. On the left hand side, this is going to vanish. 0, so you get a 10 and you got a 2 there. 2 times 10, 20. So this goes up, this goes up, so you have 8 negative of 20. That's going to give you negative 12 is equal to 4 times A plus 2 times B plus C. My C is negative 8. I need to find my B. My A is 2. So this and this gets cancelled. So I get 2 times B is equal to negative 12. Therefore the value of B is negative 6. So what I need to do, I need to take these values, all of these values, and substitute here instead of this. So this can be rewritten as L inverse of my A is 2 over S negative 1, S positive 1. My B is negative 6 divided by S positive 2, and my C is negative 8, so 8 over S positive 2 raised to the power of 2. So all I need to do is to obtain the Laplace transform of this. So that is going to be L inverse of, I can take the 2 out, it's going to be 1 over S positive 1, negative 6 times L inverse of 1 over S positive 2, negative 8 times L inverse of 1 over S positive 2 raised to the power of 2. So this is what we have got. Now this is going to be L inverse of 1 over S positive 1, that's going to be e raised to the power of negative t, negative 6 times this is going to be e raised to the power of negative 2t, and this is going to be negative 8 times e raised to the power of this. There is a shift of S positive 2 and you have a degree 2 there, so this is going to be e raised to the power of negative 2 times t, and you have to obtain the L inverse of 1 over S squared. So this is going to be 2 times e raised to the power of negative t, negative 6 times e raised to the power of negative 2t, followed by 8 times e raised to the power of negative 2t, and this is S squared. So that means t raised to the power of 1 divided by 2 minus 1, that's going to be 1 factorial, right? So if I were to rewrite this by taking e raised to the, can I take anything in common? Probably I cannot take anything in common for all of these, so I just retain it and write it as 2 times e raised to the power of negative t, and 6 times e raised to the power of negative 2t, and 8 times t times, and there's a t there, right? So 8 multiplied with t e raised to the power of negative 2 times t. So this is what I get. So this is the final solution for this question. Students, we will move on to the next one. Students, we are given this question: Laplace inverse of S squared negative 5s positive 7 divided by S positive 2 raised to the power of 3. Now this is a different way of partial fractions. In other words, we need to adopt a different type to represent this. So that's exactly what I'm going to show to you. So I'll start off by saying consider S squared negative 5 times S positive 7 divided by S positive 2 raised to the power of 3, and I'm going to represent this as A over S positive 2 followed by B over S positive 2 raised to the power of 2 followed by C over S positive 2 raised to the power of 3. So this is the way you have to fragment this component which you see in the denominator. Now if I were to cross multiply, I can rewrite this as S squared negative 5 times S positive 7 is equal to A times of S positive 2 raised to the power of 2 positive B times of S positive 2 positive C. Now if I were to take S is equal to 0, let me just do that. To begin with, what I'll do is I'll let S to be equal to negative 2. Now this will vanish, right? This is going to vanish, this is going to vanish, and I'm left with C. And then S is equal to negative 2, so this is going to be negative 2 raised to the power of 2, negative 5 times of negative 2 positive 7. Now I can rewrite this as 4, negative positive 5 times 2 is 10, positive 7 is equal to C. 4 added with 10 will give me 14. 14 added with 7 will give me 21. So therefore my C is 21. So that's the first value we have got. Now if I were to take the value for S to be as say 0, then if I were to do that, this is going to be 0 2 squared, right? So it's going to be 4 times A, and 0 positive 2 times B positive C is equal to, this is going to vanish, this is going to vanish, and I get a equation 7. But my C is 21, so I can replace that. 4A positive 2B positive 21, and you got a 7 there. If I were to push this over here, it's going to be 7 negative 21 is equal to 4A positive 2B. So I've got one system there. So this, when we subtract this is going to give me negative 14 is equal to 4A positive 2B. Now I divide by 2 both sides, and that would give me 2A positive B is equal to negative 7. So let me have this as one system. Right. Now next what I can do is I can just simply take some random value. So let me just take I've taken negative 2, I've taken 0. Let me take S to be equal to some 1. If I were to substitute that value there, I would get A of 1 positive 2 raised to the power of 2, positive B of 1 positive 2, positive C, this is 1 squared, negative 5 positive 7, this is going to be negative 4 positive 7 is equal to 1 positive 2, 3 squared is 9 times A, positive 3 times B, positive C is 21. So substitute the value 21. Now this is going to give me 3, and I can bring this 21 to this side, so it's going to be negative 21. So that would in turn would give me negative 18, and on the right hand side I have a 9A positive 3B. If I were to divide by 3 both sides, then I'm using the space, this is going to give me negative 6 is equal to 3 times A positive B. So I have got system 2, so I will use the system 2 here. So I get a 3A positive B and then negative 6. If I were to change the signs here, negative, my B will get cancelled, this will give me negative A, and I have a negative 7 and a negative 6, and in fact this is negative, so this should be positive. Yeah, so changing the signs, right? So this is going to give me negative 1, so therefore the value of A is 1. So if A is 1, I can just simply substitute the value of A into 1 or something. So you put A is equal to 1 in 1, we get, so what do we get? Negative 7 positive 2 times of 1, this is equal to, right, negative 7 equal to 2 times of 1 positive B, this is 2 positive B is equal to negative 7. You push this here, and that would be negative 7 negative 2 is equal to B, therefore B is equal to negative 9. So you have the following values, you get A is equal to 1, B is negative 9, and C is equal to 21. So you got to use all of these values into this system and obtain the Laplace inverse. So let's just do that. So therefore L inverse of this quantity, I'm going to rewrite this quantity using this. So my A is 1, we have, I just say we have L inverse of 1 over S positive 2, my B is negative 9 divided by S positive 2 raised to the power of 2, my C is 21 divided by S positive 2 raised to the power of 3. By linearity, I can rewrite this as L inverse of 1 over S positive 2 negative L inverse, I can write 9 out, 1 over S positive 2 raised to the power of 2 positive 21 L inverse of 1 over S positive 2 raised to the power of 3. Now this is going to be e raised to the power of negative 2 times t, negative 9 times e raised to the power of negative 2 times t, L inverse of 1 over S squared, positive 21 e raised to the power of negative 2 times t, L inverse of 1 over S to the power of 3. This is rewritten as e raised to the power of negative 2t, negative 9 times e raised to the power of negative 2t. This is going to be t divided by 1 factorial plus 21 e raised to the power of negative 2t. This is going to be t squared divided by 2 factorial. So if I were to take e raised to the power of negative 2t out, I would get 1 negative 9 times t divided by 1 factorial. You don't have to specify that, it's understood, positive 21 times t squared divided by 2. 2 factorial is 2. So this is the solution for this question, students. Students, we are given this question. We are expected to find the Laplace inverse of 3s positive 1 divided by s negative 1 times s squared positive 1. Now we would be using a partial fractions variation in solving this question. So this is the another important variation in partial fractions that we need to pay due attention to. So foremost, what I would do is I would just say consider 3s positive 1 divided by s negative 1 times s squared positive 1. Now this is rewritten, in fact this is represented as a over s negative 1 positive b times s positive c divided by s squared positive 1. Upon cross multiplying, I would get 3s positive 1 on the left hand side. On the right hand side, I would be getting a of s squared positive 1 positive b s positive c of s negative 1. So this is what I would get. Now first what I will do is I will let s be equal to 1. When I do that, this vanishes, so this would give me 1 squared, that's 1 positive 1 is going to be 2 times a, s is equal to 1, so 3 positive 1 will be giving me 4, therefore I get 4 over 2, and this would mean a is equal to 2. So I got the first value of a. Next what I would do is I would like to take s to be equal to 0. Now when I do that, this will vanish, b will vanish, my c will stand here, but s is 0, so the value with c, the coefficient of c is going to be negative. Now followed by s is 0, I will have a there, and s is 0, I will have a 1. So this is clearly working out in our favor because I can substitute the value of a, and from here I can obtain the value of c, and this is negative 1 negative c, therefore the value of c is positive 1. So that's neat and tidy. So I've got the value of a and value of c. Now all I need to do is pick up a random value and then substitute over in this system. So what I will do, I will pick up a value, say s is equal to minus 1. If I were to pick s is equal to, it doesn't matter, minus 1, because I was thinking of getting rid of any possible terms here, but that doesn't seem to be working out. So let's take s is equal to, say, minus 1, so I will get negative 1 squared, that's going to give me 1 and 1, so 2 times a over there, followed by negative 1, so I will have a negative b, positive c, negative 1, that's going to give me negative 2 there. So if I were to rewrite this, is going to be 2 times a, negative 2 times negative b will give me positive 2 times b, and negative 2 times c. On the left side, negative 1, so negative 3 positive 1, this is going to give me negative 2. I got a value for A. I can substitute it. My value for A is 2, so it's going to be 4 there. My followed by 2 times B. My value for C is 1. It's going to be 2 there with a negative sign, and I get a negative 2 here. So 4 added with negative 2 will give me positive 2. So it's going to be 2 times 2B followed by a negative 2 there. So negative 2, I move the 2 this side, it's going to be negative 2 followed by a equal to sign and a 2B. So negative 2 added with negative 2 will give me negative 4. I already get a 2B. Therefore my value of B is negative 4 divided by 2, which is equal to negative 2. So I get a value for B as negative 2, I get a value for A, I get a value for C. All I need to just do is substitute them over there and obtain the Laplace inverse. So this is equal to L inverse of my A value is 2, so it's going to be 2 over S negative 1 followed by my value of B is negative 2. Negative 2 times S followed my C is 1 divided by S squared positive 1. I can rewrite this as L inverse of 2 over S negative 1 followed by, I have a negative sign, I can take the negative sign, I can take the 2 out and write this as L inverse of S over S squared positive 1 positive L inverse of 1 over S squared positive 1. So this is what I have got. So in fact I can take the 2 out. So if I were to take the 2 out and operate on using L inverse, this would be e raised to the power of t because of the shift being S negative 1 followed by negative 2 times, this is S over S squared plus 1, that would give me cos t, and this is 1 over S squared positive 1, and that is going to give me sin t with a positive sign. So this is the solution to the question, students. Students, we are given this question: find the Laplace inverse of 1 negative S of 5 positive 3S divided by S of S positive 1 raised to the power of 2 positive 1. Now we will be employing partial fractions, and this is the variation that I have just spoken about in the previous question. So let us apply the same variation for this. So what I will do is I will first consider 1 negative S of 5 positive 3 times of S divided by S of S positive 1 raised to the power of 2 positive 1. Now I'm going to rewrite this as A over with this S followed by BS positive C divided by S positive 1 raised to the power of 2 positive 1. So this is the way you have to follow. Now cross multiplying, I get 1 negative S times of 5 positive 3 times S is equal to A of S positive 1 raised to the power of 2 positive 1 positive B S positive C times of S. Now I need to get rid of these quantities one by one so that I am able to get the values. So first thing first, what I would do is I would just take let S be equal to 0. If I were to do that, this entire quantity will get vanished. So this is going to be 0 positive 1. That's going to give me 1, and 1 squared is 1, and I got a 1 over here, so it's going to be 2 times A. This is 0 and this is 0. In fact, this would clearly give us a value of A being equal to 1 over 2. So that is so simple. Now having obtained the value of A, now let me just take the value of S to be as negative 1. If you were to take the value of A to be as negative 1, this will vanish, but A will still remain, and followed by S is negative 1, so this is going to be negative B positive C of negative 1, and I have a negative 1 there, so it's going to be 1 negative of negative 1 times 5 negative 3, because s is equal to negative 1. So this will give me a 2, and it's going to be positive, so it's going to be 1 positive 2 is equal to my a is 1 over 2, and this will give me a positive b and a negative c, and 2 positive 1 or 1 positive 2 is going to be 3. I can move this 1 over 2 to the left. That's going to be negative sign there, so you get a b negative c equal to 6 negative 1 over 2, which is going to be 5 over 2, which is going to be equal to b negative c. So I got a equation there. Now I have taken the value of s to be as 0, s to be as negative 1. Now let me take the value of s to be as 1, so that I can get a system and then I can solve it. So if I take s to be as 1 on the left side, I get a 1, negative 1, 5 positive 3, that's fine. So this is going to be s is 1, 1 positive 1, 2, 2 squared is 4, 4 positive 1 is 5, and s is 1, so b positive c, and that's it. So a is already equal to 1 over 2. I substitute the value here, so it's going to be 5 over 2, positive b positive c, and this is going to be 5 positive 3, 8, so 1 negative 8, it's going to be negative 7 is equal to 5 over 2 positive b over c. I will use the space here. I will move this 5 over 2 to the left, so it's going to be negative 7 negative 5 over 2 is equal to b positive c. This is going to give me 14 negative 5 over 2 is equal to b positive c. So therefore b positive c is equal to negative 19 over 2. So I take this as 2, I take this as 3. So I have b negative c is equal to 5 over 2. B positive c is equal to negative 19 over 2. I add this, I get 2 times b is equal to 5 over 2, negative 19 over 2. I take the LCM as 2. This is going to give me 5 negative 90, which is negative 14 over 2 is negative 7. So 2b is equal to negative 7, therefore b is equal to negative 7 over 2. So I get the value for b. I can substitute it in this or in this. So let me substitute it in 3. So negative 7 over 2, positive c is negative 19 over 2. So I move this on this side. So c is negative 19 over 2, positive 7 over 2. So I take the LCM. So negative 19 positive 7, that's going to give me negative 12. So negative 12 over 2 is going to give me negative 6. So my c is negative 6. So I've got a c, I've got a b, and I've got a a. So we need to substitute these values now. So now instead of this I would have this. So this is going to be L inverse of a, my a is 1 over 2 divided by s, my b is negative 7 over 2. So let's substitute it there. So negative 7 over 2 times s divided by s positive 1 raised to the power 2 positive 1, and my c is negative 6. We got negative 6 for c, so substitute that. So this is what we have got. So we can rewrite this as L inverse of 1 over 2. I can take it out, so it's Laplace inverse of 1 over s. 7 over 2 I can take it out. This is Laplace inverse of s divided by s positive 1 raised to the power of 2 positive 1. So I'm going to split it like this and write it. And negative 6 I can take it out, and this is going to be L inverse of 1 over s positive 1 raised to the power 2 positive 1. So we need to do some calculations here. So clearly you can see that there is a shift of s positive 1 taking place in the denominator, but there isn't any here. So to achieve that, I'm going to add 1 and subtract 1. So I will have to rewrite this as, I'm not going to take the Laplace inverse as such now. I will just set up these terms. So this is going to be 1 over 2 times L inverse of 1 over s negative 7 over 2, and I'm going to rewrite this as L inverse of s positive 1 divided by s positive 1 raised to the power of 2 positive 1. This is one component, followed by L inverse of 1 over s positive 1 raised to the power of 2 positive 1. This is the another component, followed by negative 6 times L inverse of 1 over s positive 1 raised to the power of 2 positive 1. So this is, I'm just writing it as it is. Now I'm applying Laplace inverse. So this is going to be 1 over 2 times L inverse of 1 over s, that is going to be 1, followed by negative 7 over 2. The shift is s positive 1 as I mentioned to you. So if I were to apply the shift, this is going to be e raised to the power of negative t L inverse of s divided by s squared positive 1, and of course I will have to be careful because the 7 over 2 is coming in, followed by, if I were to apply the shift, this is going to be e raised to the power of negative t and Laplace inverse of 1 over s squared positive 1. So this is what I have got for this term, followed by negative 6 times the shift. I'm applying the shift, so e raised to the power of negative t followed by Laplace inverse of 1 over s squared positive 1. So this is what I've got. Now this is equal to 1 over 2 negative 7 over 2 e raised to the power of negative t. This is going to be my cos t, negative e raised to the power of negative t. This is going to be my sin t, that's fine, followed by negative 6 times e raised to the power of negative t. This is going to be my sin t. Now let me remove the parenthesis. So this is going to be 1 over 2 negative 7 over 2 times e raised to the power of negative t times cos t, positive 7 over 2 times e raised to the power of negative t times sin t, negative 6 times e raised to the power of negative t times sin t. Okay, so I can very well take e raised to the power of t out. Now I can in fact simplify these two components, right? So this is going to be, I can take e raised to the power of negative t out, I can take a sin t out. Now if I were to do that, I get 7 over 2 negative 6. That is going to be, I take the LCM as 2, 7 negative 2 times 6 is 12, which is going to give me negative 5 over 2. Of course you get e raised to the power of negative t sin t. So I would write this first, negative 7 over 2 times e raised to the power of negative t cos t, and this is going to give me negative 5 over 2 times e raised to the power of negative t times sin t. Now I can take a common quantity of e raised to the power of negative t out. In fact I can take 2 out, so that would mean I will have a cos t with a 7 there, right? And since I've taken a negative sign out, this will become positive 5 times sin t. So this is what we've got as the final solution. You can check it out and see, students. We will do one more question on Laplace inverse transforms using partial fractions, students. So we've been given this to obtain the Laplace inverse of this component, 8 positive 3 times s divided by s squared positive 1 times s squared positive 4. So the degree being 4 here. So what I will do, I will start off by consider 8 positive 3 times s divided by s squared positive 1 times s squared positive 4. I'm going to rewrite this as as, in fact I'll rewrite it as a positive bs. A positive bs divided by s squared positive 1, and then followed by c positive ds divided by s squared positive 1. I'm just writing it for the sake of convenience. You can always interchange the presence of s depending on what you want, but I prefer it in this fashion, so I'm using it. Now cross multiplying, I would get 8 positive 3 times s is equal to a positive bs. S squared positive 1 will get absorbed, giving me s squared positive 4, followed by c positive ds times s squared positive 4 will get absorbed, giving me s squared positive 1. Now the question is to eliminate and to find the value of a, b, c. So what I would do is I would start off by taking s is equal to 0. That's a standard substitution we can use. So if I were to take s is equal to 0, my b will go, leaving me with 4 times a, followed by my d will go, leaving me with c, and on the left side I get 8. So that is one particular system we have got. Now the next thing is, if I were to take s squared is equal to, but the problem is we wouldn't be able to take s squared is equal to negative 1, so that would give us a complex quantity. Now what I would do is I would just take the values for s in this fashion. Say then I need to solve it. So I will start with s is equal to 1. If I were to take s is equal to 1, I would have a positive b times s is equal to 1, so it's going to be 1 positive 4, it's going to be 5 there, followed by c positive d, and 1 positive 1 is going to be 2. S is equal to 1, so that would mean 8 positive 3, that would give me 11. So if I were to rewrite this, I get 5 times a positive 5 times b positive 2 times c positive 2 times d. This is one system is equal to 11. Now I will have to take one more value for s. So let me name it as system 2 or equation 2. This is going to be 1. Let me take s to be equal to negative 1. If I were to take s is equal to negative 1, I substitute here. This is going to be a negative b, and s is equal to negative 1 positive, so 1 positive 4 is going to be 5 positive. C, s is equal to negative 1, c negative d, s is equal to negative 1, that's going to be 1 positive 1 is going to be 2, and s is equal to negative 1, that's going to be 8 negative 3, which is 5. This is going to give me 5 times a negative, 5 times b positive, 2 times c negative, 2 times d. This is what I get. So I get system 3. Now I would have to get one more equation, because as of now we can eliminate one variable from here, so that leaves us with 3. So we need to simultaneously have subsequent systems. So you can clearly see that if I were to use this substitution technique, I would be needing more equations for solving, but there is an easier way. So what I would do is I would expand these things, and that would give me a times s squared positive 4 times a, and bs cubed positive 4 times b times s, and then followed by c times s squared, followed by c positive ds cubed positive ds. On the left hand side I got 8 positive 3 times s. Now what I will do is I will equate the coefficient of s cubed. So I'm going to write that, equating the coefficient of s cubed. So what do I get here? I get a s cubed here, that's going to be b. I get a s cubed here, that's going to be d, and the coefficient of s cubed is 0. So this is one system. So next I would be equating the coefficients of s squared, and that would get me s squared. I get a here, and then I get a c there. Is there anything else I have? No. A, c, and that's going to be 0. Now next, equating the coefficient of s. Coefficient of s, I get a 4b there, and then coefficient of s, I get a d there, and coefficient of s, I get a 3 there. So this is my system 3. Next, constant term, equating the constant term. So what is the constant term? I got a 4a here, 4a, then I get a c there. Anything else on the left side? I get an 8 there. So this is going to be 4. So I've got 4 systems easily. So what I would do is I would try to solve from 2. I can get a is equal to negative c. I substitute the value here, a is equal to negative c. Okay, put a is equal to negative c in 4. So in place of a, I substitute negative c. So this is going to be 4 times of negative c positive c is equal to 8. So negative 4c positive c, which is negative 3c, and I get c is equal to 8 over 3 with a negative sign. So c is equal to negative 8 over 3, but my a is negative c, so therefore from here a is positive 8 over 3. So I got that. I got the value for a, I got the value for c. Now let me see what I can do with b and d. So over here, b positive d is equal to c is equal to 0, therefore b is equal to negative d. I get b is equal to negative d, I substitute it here. So what do I get when I do that? So I get 3 is equal to 4 times b is equal to negative d. So I substitute that and I get a d there, and over here negative 4d positive d, this is equal to negative 3d is equal to 3. Therefore my d is equal to negative 1, my d is equal to negative 1, my b is equal to positive 1, right? Because b is equal to negative d. So I've got a, b, c, d, all the values I've got. All I need to do is to substitute them into the system. So this is equal to L inverse of my a is 8 over 3, and my b is positive 1 divided by s squared positive 1. My c is negative 8 over 3. My d is negative 1. That's going to be negative s divided by s squared positive 4. So now I need to simplify this. I can rewrite this as 8 over 3 L inverse of 1 over s squared positive 1 positive L inverse of s over s squared positive 1 negative 8 over 3 L inverse of 1 over s squared positive 4 negative L inverse of s over s squared positive 4. So I got that. Now this is going to be 8 over 3. Laplace inverse of 1 over s squared will give me sine t. This is going to give me cos t. This is going to give me It's 2 squared there, right? So sine 2t times 1 over 2, that's what it will produce. Negative, this is going to be 2 squared, so this is going to be cos 2t. So if I were to rewrite this, this is going to be 8 over 3 sine t followed by 2 divides here 4 times, so negative 4 over 3 sine 2t followed by cos t and cos 2t. You can either write it as cos t negative cos 2t as the first quantity, followed by 8 over 3 4 over 3. So in fact you can take 4 over 3 out, and that would give you 2 times sine t negative sine 2t. So this is your solution, students. Thank you so much.